Hello everyone and welcome to my channel. Today we are going to talk about space-based solar power, or SBSP for short. This is the idea of collecting solar energy in outer space and transmitting it wirelessly to Earth. Sounds like science fiction, right? Well, not anymore. In this video, I will explain how SBSP works, what are its advantages and challenges, and what are some of the current projects and plans to make it a reality. SBSP is based on the concept of solar power satellites, or SPS. These are large structures that orbit the Earth at a high altitude, usually in a geostationary orbit, where they can receive sunlight almost continuously. The SPS would convert the sunlight into electrical energy, and then use a microwave transmitter or a laser emitter to beam the energy to a receiver on Earth's surface. The receiver, also known as a rectenna, would convert the microwave or laser beam back into electricity and feed it into the grid. The main advantage of SBSP is that it can provide clean, renewable, and non-intermittent energy to any location on Earth, regardless of weather conditions or time of day. Unlike terrestrial solar power, SBSP does not suffer from atmospheric losses or shading effects, and can collect more energy per unit area. SBSP could also reduce greenhouse gas emissions and fossil fuel dependence, and potentially create new markets and jobs in the space sector. However, SBSP also faces many technical, economic, and political challenges. The biggest one is the cost of launching and maintaining the SPS in orbit. According to some estimates, a single SPS could weigh several thousand tons and cost billions of dollars to build and launch. The cost of electricity from SBSP would have to be competitive with other sources of energy, which may require significant reductions in launch costs or improvements in efficiency. Another challenge is the safety and reliability of wireless power transmission. The microwave or laser beam would have to be carefully controlled and regulated to avoid interference with other satellites or aircrafts, or harm to humans or wildlife. The beam would also have to cope with atmospheric turbulence and attenuation, which could reduce its power and quality. Moreover, the SPS would have to withstand the harsh environment of space, such as radiation, micrometeoroids, debris, and thermal stress. Despite these challenges, there are several countries and organizations that are actively pursuing SBSP as a viable option for the future of energy. For example, in 2023, Caltech launched a small experimental satellite called SSPD-1, Space Solar Power Demonstrator 1, which tested some prototype components of a possible future SPS. The satellite deployed a lightweight frame for mounting solar arrays, tested different types of photovoltaic cells for efficiency and durability, and demonstrated wireless power transfer using microwaves. In 2022, China announced that it had started construction of a testing base in Chongqing for SBSP research. The base would include a ground station for receiving microwave power from orbiting satellites. China also has plans to launch a series of experimental SPS by 2025. In 2021, the UK government commissioned a study on SBSP by Fraser-Nash Consultancy. The study concluded that SBSP could be technically feasible by 2050, but would require significant investment and international collaboration. The study also identified some key areas for further research and development. In 2015, Japan's space agency JAXA unveiled its roadmap for SBSP development. JAXA aims to launch a 10-kilowatt demonstration SPS by 2030, followed by a 200-megawatt pilot SPS by 2040, and eventually a commercial-scale SPS by 2050. In 2008, Japan passed its Basic Space Law, which established SBSP as a national goal. As you can see, SBSP is not just a fantasy anymore. It is a serious and ambitious endeavor that could revolutionize the way we produce and consume energy. However, it is also a complex and costly one that requires careful planning and coordination among multiple stakeholders. Whether SBSP will become a reality or remain a dream depends on how we overcome the technical hurdles and address the economic and social issues involved. If you liked it, please give it a thumbs up and subscribe to my channel. Thank you for watching.